Consider three linear equations in R2 which are pairwise distinct. If this system has unique solution x, y, then it is said to be consistent. The necessary and sufficient conditions for the system of equations to be consistent are: determinants of a1, b1, a2, b2 is not equal to 0. Determinants of a2, b2, a3, b3 is not equal to 0. And determinants of a3, b3, a1, b1 is not equal to 0. And determinants of a1, b1, c1, a2, b2, c2, a3, b3, c3 is equal to 0. Here x, y, it is the unique solution of each pair. Now consider the pair x is equal to b2, c3 minus b3, c2 upon a2, b3 minus a3, b2. Y is equal to minus a2, c3 minus a3, c2 upon a2, b3 minus a3, b2 is the solution of this pair of equations, and this is also the solution of a1x plus b1y plus c1 is equal to 0. a1 into b2, c3 minus b3, c2 upon a2, b3 minus a3, b2 minus b1 into c3, a2 minus c2, a3 upon a2, b3 minus a3, b2 plus c1 is equal to 0. Therefore, a1 into b2, c3 minus b3, c2 minus b1 into c3, a2 minus c2, a3 plus c1 into a2, b3 minus a3, b2 is equal to 0. Therefore, determinant of a1, b1, c1, a2, b2, c2, a3, b3 and c3 is equal to 0. This proves that the conditions are necessary. Now we prove the sufficiency of the conditions. Let determinant of a1, b1, c1, a2, b2, c2 and a3, b3, c3 is equal to 0. Therefore, a1 into b2, c3 minus b3, c2 minus b1 into a2, c3 minus a3, c2 plus c1 into a2, b3 minus a3, b2 is equal to 0. Also, a2, b3 minus a3, b2 is not equal to 0. a1 into b2, c3 minus b3, c2 upon a2, b3 minus a3, b2 plus b1 into c2, a3 minus c3, a2 upon a2, b3 minus a3, b2 plus c1 is equal to 0. Now let us take x is equal to b2c3 minus b3c2 upon a2b3 minus a3b2, and y is equal to c2a3 minus c3a2 upon a2b3 minus a3b2. Therefore, we have a1x plus b1y plus c1 is equal to 0. Thus, xy is a solution of the given system.